Hello! Today we're talking about factors affecting reaction rates. So you can have some fast reactions like explosions, or you can have things that are slow like rusting. These are measured over time, and we're trying to look at how can these be influenced so we can change things to go faster or slower. Now first we need to think of what actually happens when a reaction occurs. So this is talked about with collision theory. Now, reactions happen because of collisions. And in order for a collision to be successful, they need to have enough energy, called activation energy, and in a correct orientation. So here we see that we're trying to make these new compounds of A2 and B all by itself. If it collides in the right orientation, but not enough energy, they just bounce off each other. They might have enough energy, but these A particles aren't able to overlap and bond, so it doesn't occur. So you need the correct orientation for the reactants to be close enough to attract, and in order for the enough energy in order for them to get close enough. And if the number of collisions can happen faster, then the reaction will be quicker. So this is really focused on the idea of collisions being a key component of reaction rates. So, factor 1, temperature. If you get a higher temperature, of course you're going to have a faster rate. Molecules move faster. So you get more collisions, and they're more energetic, meaning they have that higher activation energy possible. So let's think about this. If you have a higher temperature, something like food cooking, what happens to the amount of energy? Well, that would go up. Orientation, would it affect how the molecules are positioned? No. Number of collisions a second? Yes. Right? Most students have no problem thinking about the increase in temperature. That's why I want you to look at the decrease of temperature. So let's think about what it would decrease. Well, with a lower temperature, less kinetic energy, the energy would be lower. That one's nice. It wouldn't affect the orientation, and the number of collisions per second would go down. So why does having a lower temperature slow down a reaction? Since the molecules are colliding less, there's less possibilities for a successful collision. Since there's less energy per molecule, there's less possibility of colliding with enough activation energy in order for a reaction to occur. So activation energy and number of collisions go down with temperature. Key part that there's two parts in order to correctly explain temperature and its changes. Let's look at concentration. With a higher concentration, that's going to produce a faster rate. You have more particles moving faster. More particles in the same space means more frequent collisions. Something like air, regular burn. Pure oxygen, 5 times the amount of oxygen, going to burn 5 times as fast. So, in this idea of energy, do we have more energy having more particles? No. Does it affect the orientation, how they're positioned? No. Number of collisions in a second? Yes. Because you have more particles, they're going to be more likely to collide. Now let's focus on the lower. Why does having a lower concentration, less reactant, slow down a reaction? What may decrease? Energy? No change. Orientation? No change. Number of collisions per second would decrease, having less particles. So the why for this, having less particles available for reaction is going to decrease the likelihood that they're going to react in a successful collision, therefore less likely to react overall. Let's look at our next factor, surface area. So surface area is essentially the place at which the reactants can interact at. So if you have a higher surface area, faster reaction rate, more of the reactant particles are exposed, more frequent collisions in the same time frame. So in a sugar cube, only the outer surface can react with the water. However, if you had it all mixed up and granulated, just meaning like little white crystals, then all of it can react all at once. So let's focus on our ideas here. Is energy any higher with it being crushed? No. Orientation? Not really. It kind of seems that way, but not really. Number of collisions in a second? Most definitely, yes. So what about lower? What is having a small surface area, meaning large pieces? Kind of contradictory. Small surface area means larger pieces. How does that slow down a reaction? Well, it affects the number of collisions. So with a smaller surface area, less particles are available to interact and collide. So therefore, the reaction rate will be decreasing due to this less collisions per second. We're going to come back in part 2 and continue on our discussion about these factors and their effects.